diarrhea. It's corn maze in the middle of the day.
It's the homeschool day until.
Yeah. I see. Yes, I do in fact have something to give to one of you. Okay.
I saw this whenever I walked in.
I need my pre-calculus book. All right. What numbers did we do?
Something. 2 through 8. 6 through 8 or 18. 2 through 18.
We're on to what?
5. You did 4, 8. Oh, gosh, you actually use your whole paper. Yes.
Number 2. The domain x cannot be 2 or negative 2. Remember the real numbers.
2?
No, I'm looking at number 1.
Oh,
Just
yeah.
kidding.
Okay.
The domains x can't be negative 4, and x equals negative 4 is an asymptote. And number 4, x cannot be negative 3, negative 5, x equals negative 3, and x equals negative 5, and y equals 0 are the asymptotes. Number 6, x is not equal to 4, and x equals 4 is the asymptote. 8, the domain is x cannot equal 3 or negative 1. It has asymptotes at x equals 3, x equals negative 1, and y equals 1. 10 is on another page. If you'll go back and use this video at some point, it may be a little bit choppy because I broke the internet on Sunday and forgot to come back and fix it yesterday. So using my cell phone, telephone's internet.
How did you break the internet?
I accidentally broke the plug on the power thing.
Yeah, the second one did, right? The first one was great.
Gosh, allergies all of a sudden going crazy.
All of a sudden, for me, it's just existed for the past like 2 months.
Probably because you walked in from being at the corn maze. Brought all that stuff.
It wasn't actually dusty today because it rained out there.
It's not the dust. Dust is not, people aren't allergic to dust,
Yeah, it was annoying.
to dirt.
It just gets in your nose and then you sneeze. Allergies is just.
You're allergic to pollen in the air maybe, or other stuff. No, it's not dust.
I know that the rain helped.
Okay. Oh yeah, we got pictures. Let me grab the thing, blow my nose, and turn the TV on.
Have you seen that emote in Fortnite? It's so stupid. It's a hot dog rain mustard bottle.
Oh my gosh, you play Fortnite? That's crazy.
I really don't much. I literally played.
Because there's pictures.
I'm kidding. For 10?
Yeah, it looks like that right there.
I don't have time to play Fortnite anymore.
On 2.5, number 10.
I do watch TV.
Graph the function.
Only The Simpsons.
Literally says so right there. Literally says so right there.
Because there's so many episodes of it.
37, actually no, 38 now. Seasons. 38 seasons.
Of what? What dumb show are y'all watching? Oh, The Simpsons. I don't quite understand. Like, The Simpsons to me is not all that funny. I don't know quite why it got, like Futurama, I think it's hilarious. I like Futurama a lot, but Simpsons is like, it's vaguely inoffensive, but it's not that funny. It's just kind of like, whatever. It's not, I don't understand why it became as popular as it did.
I don't think anybody does.
Well, a lot of people just love it, but I don't know, whatever. I mean, it's fine. It's
Yeah, I can sit there for 3 hours and just watch that.
it's better than Family Guy, but that's not hard to do. But it is.
Family early seasons. The early seasons of Family Guy were apparently good. I haven't seen it. But I haven't seen it, nor do I think I
I
will.
bet they just like random material and just fucking do it.
Stop touching.
Just constantly trying to take your bits of
I am. And I'm gonna So good.
Number 10.
I don't want to.
Looks like that.
Oh, are we supposed to draw the graph?
It does say graph it.
Oh, well.
It literally says graph the function. But apparently you and Malcolm are struggling to be able to read today.
Yeah, I don't know
Yeah,
how I
it's
managed to
better.
miss those two as well as you.
I just use my graphing calculator, but I actually remember what it was, so
Okay.
even though I did myself right.
No, so did I.
Number 12.
Wait. Oh, never mind. I saw it.
Wait.
Let's try to read the intercepts.
It's right there.
Oh wait, what's that other asymptote? Like 3?
It's like 0.
I didn't put that.
Oh, I knew that. But why did I write that?
6.
What is 6? Why is it -2?
Oh, they just did like.
There we go.
They're counting by twos. This is -4, and this is 4. They're counting by twos on the grid lines. They usually do, to be honest.
I don't look at the answer key much.
No kidding.
It's not like we have the answer.
Number 14. Yeah, but every time we do graphs, we do, and they count by twos. Almost always. Number 14.
I'll remember that a little bit. I'm so happy you don't have to graph these by hand anymore.
You do have to graph them by hand.
It's just not as hard.
Yeah,
Just
right.
we can look at a picture and then graph is what he's saying. We don't
You have sanity check. You have to do a lot of work still.
Yeah, but less than it would be if we didn't have graphing calculators.
On these, arguably, that's false. It's about the same.
Less brain power.
brain power.
Maybe. Number 16. I'm trying to give you hints for like not failing the test because you didn't write enough stuff down. So that's what I'm doing right now.
I failed the test for more reasons than just that.
And we went through 18?
Yes.
18.
That one looks so funny.
Yeah.
Looks like a little smiley.
Any questions on those?
Number 6.
Number 6.
I would have said number 4, but I got both those two wrong.
I got both.
No, the answer for number 4 said it's weird.
Number 4. Number 4?
No,
Okay.
number 6.
Oh, number 6.
Nathan said 4, but
I said 4, he said
Oh,
6,
okay.
so we need to stick to not compare which one.
he just needs one.
As long as we do one of those two, we're fine.
They're both kind of easy, but that's all right.
You say that about every single problem.
I definitely do not.
He
or at
says
least
that
a lot
about
of
a few
them.
problems.
A lot of them that I ask about.
You did the easy ones wrong.
Yes.
I may have just misunderstood one of the things.
You may have just not read the instructions good. That's possible.
Well,
I don't like reading because of instructions. I'm just like skim over it and figure out what I have to do.
That didn't work out for you. We were supposed to graph? Oh, that's
I
funny.
didn't even try skimming over that one. I was just like, probably the same instructions as the last one.
Number 6. The equation is f of x equals x squared plus 9x plus 20 over x minus 4. And we were supposed to find the domain and the equations of any horizontal or vertical asymptotes.
That's why I'm stupid. I just misunderstood some of my notes.
Well, we'll finish doing it anyway because I think Landon still wants to look at it. So the domain is x such that x cannot equal 4, right?
I did get that part.
X is a member of the real numbers.
I don't like that part. I'm like, I feel like most of it is just the real numbers. But there's also like those two things that are always like.
Most of the ones that we do will be a member of the real numbers. I mean, that's true.
Is it alright that I did mine in the other way of writing domain?
That's fine.
Alright.
As long as you did it right.
I did open parentheses negative infinity, comma 4, union with 4.
Yeah, all round brackets, no square brackets. Great. Okay.
I just thought.
So, Now we need to figure out whether there's horizontal or vertical asymptotes. So what do we need to look at first?
The degree of the numerator and the degree of the denominator.
The degree of the numerator, the degree of the denominator. The degree of the numerator is larger because 2 is bigger than 1. Gasp. Okay, so the fact that the degree of the numerator is greater than the degree of the denominator, what do that tell us? No horizontal asymptotes. Does it have a vertical asymptote?
It does.
It definitely does. How do we find that?
What x cannot be.
It's what x isn't, and x, or what x cannot be, and x cannot be full.
Yeah, I got all that. I just thought I wrote it wrong, but then I realized I didn't.
What? Yeah. What other questions do we have on 2 through 18?
Let's do.
Pretty good.
Yeah, I was still.
16. You sound like you're not being serious. Are you being serious or no? Okay, we're not doing 16. Okay. You need 16. You have a question about 16.
Not serious.
He sounded not serious.
I just said it in a.
Okay. Okay.
16.
I guess we'll do 16. F of x equals x times the quantity x plus 6, quantity squared, times x minus 4 over x squared minus 5x minus 24. Okay.
18 looks really strange.
The instructions say, determine any asymptotes and intercepts, graph the function and state its domain, then describe and analyze the end behavior.
Oh yeah.
Great. What do we need to be doing now?
We need to be like distributing the top.
Should we distribute?
We may or may not want to do that right now, depending on what else is happening.
Hold on.
Because factored version is going to be easier to deal with, and we're going to have to shove numbers in a minute, and all of those things.
Oh yeah.
What's the degree of the numerator?
4. 4.
Yeah, it's 4.
Oh, yeah, okay.
So we don't actually have to factor it. Never mind.
So, what's the degree of the denominator?
2.
2. So the degree of the numerator is greater than the degree of the denominator. What does that tell us?
There is 0 horizontal asymptote.
No horizontal asymptotes. I don't know. Same reason you were doing it wrong on your homework. I don't know. Okay, so there's no horizontal asymptotes. Find the vertical asymptote. We're going to factor this thing. X. Doesn't factor, does it? 6 and 4, 12 and 2, 8 and, oh yeah, 8 and 3. Yep. 8, 3 plus minus. Great. So it has a vertical asymptote at x equals 8 and x equals negative 3. We can go ahead and start the graph. At 1, 2, 3, 4, 5, 6, 7, 8. Dot in a line.
What did you do?
I don't know.
That didn't work. 1, 2, 3. To be clear, boys, this is the order you should be doing these in. On paper and then on your calculator.
Well, we were looking at the graph, but his graph is different from mine.
Then something's wrong with one of your graphs. That's fine. But what I'm telling you is you need to use your thinker before you use your poker,
Aw, I like my poker.
which is good life advice, to be honest. Okay,
I guess.
what now?
Take me to your graph.
Now we graphed
Now we
it.
graphed it.
What do we need to do?
Get some points and just like group and then group.
What in the world is that?
We should get some points. I agree.
Graph this. What does yours look like?
I haven't graphed it yet.
No, when you graph it, what does it look like?
It looks like a graph.
No, because this is Landon.
What are we going to put in here? Put your calculators down.
We're going to, what's the word? Put a number in.
Great, what numbers?
Of x, and then we apply it to the x.
That's not what you meant to say, but
-4.
Whatever I was trying to say, we put it.
-4 is a good choice. What else is a good choice?
-3. Wait, no.
No.
Wait.
Definitely not -3.
-16.
-16 is a great choice.
-3.
-2.
No, we want.
-3 is still not a good choice.
-2.
-2.
Sure.
4.
0.
16.
7.
2.
13.
Someone said 13.
13.
Yeah, I just ignored the 13. 13 was useless.
Oh, yeah. Why did you say 13? Wait, why?
We've already got a 16,
Oh, yeah. Well,
so we don't really need, I mean, if you want to get something even bigger, but
27.
yeah, like, or 100 or whatever, yeah. Okay, so now you can shove it in there and open up your table, right?
My calculator's being stupid.
Your calculator only does what you tell it.
No, I'm pretty sure it is being stupid because we put in the same equation for our y equals and came out with two different graphs.
Calculator can't.
Then you put it in wrong, or you did. The calculator's not being stupid.
Oh, no, my thing just went away.
No, I'm telling you, something is not right about how you plugged it in.
Yes, you are correct.
You have it zoomed in.
-4 is 32 thirds.
32 thirds.
32 thirds.
So 10 and 2/3.
Oh, I figured you wanted it as an improper.
I definitely don't. Not on a graph. not on a graph. Where is 32 thirds? I don't know. Somewhere. I don't know where that is. Okay. What about -16? 4,039ths. What is that?
I'm doing the math.
Oh, okay, good.
Why can't I get out of it?
For -16.
Yeah.
102.56.
Yeah. Yours is nice because it gives it to you in decimals.
Does he do it fractions?
It does.
Dude, it's unfortunate.
What about -2? I'll guarantee you.
19.2.
I'll guarantee you that there's a setting in there that'll let you change that.
There
but-
probably is. I just haven't found it.
0 is 0. 4 is 0.
0. We might need to put something in between those.
Yeah, agreed.
Probably so.
2.
Well, 16 is 611.36.
2 is 100.
I don't even care what its point. We don't have that granular.
8.53.
Yeah. And what else do we have? 7 is.
You probably want, since you did, you did have -2. Just kidding. That's fine. 7 is what?
-354.9.
That's a fun number.
9 is 843.75.
Is your graph fixed now?
Yeah.
Because we have the same table, but we have
Fixed it.
different graphs.
Okay. -4. And 10 and 2/3.
Nope, I still have the same graph.
That's not a word.
Oh wait, I take it back. It's correct now.
What is it?
Look, I got a big.
Oh,
Negative 16, and it's still going up. Negative 2, negative 19. 0, 0, 4, 0. So you need some more information, right?
Okie doke.
Wow, that one's low.
Something else that we didn't calculate in this that we should do a little algebra on is the intercepts. Especially since it's easy to do. How do we find the zeros of this function?
We make x equals 0 and y equals 0.
Yeah, the x equals 0 is, that one's easy, right? We already did that, 0, 0, done. The y equals 0 is the one that takes a little bit more work, although a lot of the work is done for us, right? So we put y equal to 0. Whenever you find the intercepts, the zeros, what's gonna happen to the denominator? It's just gonna go, because 0 times that is, right? So all we're sticking in is the numerator, right? Oh, I did. You're right. So it has zeros at x equals 0 and negative 6 and 4. What do we know about the one at negative 6?
They're also doing at 6. Wait, no.
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 What does the fact that it's squared tell us? It's got a multiplicity of 2. What does that tell us about that 0?
There's going to be 2 lines of it.
No,
No.
it's not what it tells us.
It's going to touch, but it's not going to go.
It's going to touch but not cross. True enough. So at negative 6, negative 1, 2, 3, 4, 5, 6, it's going to kiss the graph, right? So we know that that one's up there, right? We know that that one's up there, right? There's something happening right there. We know that this is going to go up here. We need to know how high it's going to go up here before it sinks back down, right? Because it's here and it's hitting here, and we need to know what here is, which is probably positive 2, right? So it's up at 8-ish, right? So in the middle, it's going to be here and then up to here and then that, right? It probably curves. Does it curve a little bit? Do we have another one in here? We have 7 and negative. We'd have to do some of these, but it probably has a little, but it may not.
It looks pretty similar to that.
Okay, so it doesn't. And then over here, it's all in the positive range, right? So it's gonna be like this and then like that, right?
No, we didn't. Never mind.
It's cute.
Okay.
Does that answer whatever question you had about it?
It answers the question about the problem is about how my calculator gets the correct table points but not the correct graph.
I cannot stress enough. Don't have some discipline. Do the handwork first and then look at the graph. Because then you'll be less confused. Because you'll be like, okay, I must have punched something in wrong, and then you figured that out, and oh, I did. I left off a parentheses, or I squared, or whatever when I punched it in. So use your thinker before you use your clicker, or your writer, or what? Well, you're writing while you're thinking, right? Make sense?
Yeah, I'm very confused.
You're confused about what?
Yeah, I gave you all the table points, but then the graph's still way off.
Is the graph way off?
Oh yeah, it's way off.
It's a squiggly line. But his table was right. His
Your window is wrong.
Yeah, probably.
It's not a squiggly line. It's not remotely
Yeah,
a
but it's not
squiggly
that,
line.
though.
It is
It was
that.
a squiggly line earlier.
It is clearly not a squiggly line.
It was doing up and down.
It is clearly not.
I don't know, did it change it?
Probably.
Because earlier it was just going up and down.
just set your window to a setting that's going to make any sense. Just like change your window, because look at the picture. Look at the way you see how these are like really tight,
Yeah.
and it has a different this zoom, the auto zoom that it thinks you want, because all any of them can do with auto is make its best guess that this is how they're going to want it, right? So you just need to manually set the window to like this big by this big, something square, whatever else, and then it'll look normal.
Yeah, that changed again. It was something different earlier.
Yeah. Okie smoky dokey. Let's talk about slant asymptotes. I think, right? Isn't that where we are? Sound correct? Slant asymptotes and then solving the things and then we out. Sounds good. If we're extremely lucky, we get to both of those things today.
It's so right, though. It's not that.
Which we probably will, because slant asymptotes are not very difficult, actually. Oblique asymptotes. Okay, so we've talked about how to find if it has a vertical asymptote, if it has a horizontal asymptote. There are actually two other possibilities. There's an oblique asymptote, and you would think there's an asymptote, but there's not because there's a hole. Those are the two other possibilities. This is still 2-5. If we're, like I say, if we're extremely lucky, we will finish 2-5 today, which I think we can, because oblique asymptotes and holes is not going to take very long, and then solving them is really review. Actually, all of this is technically review. All of this is Algebra 2 stuff. Yeah. This is all review.
I remember there's like A's and B's and like division and
Why is there A's and B's? I thought it would be X and Y.
Okay, so
stop taking my stuff.
if the degree of the numerator is greater than the degree of the denominator, what is true? What do we know? There's no horizontal asymptote. There might be an oblique asymptote. Okay? If the degree of the numerator is exactly one more. Degree numerator, degree denominator. Denominator. If it is exactly one more, if this equals the degree of the denominator plus 1.
So it's 3. 3 on top of 2 on the bottom.
3 on the top and 2 on the bottom. Then it has a oblique asymptote. Where is the oblique asymptote? This is what you have to do to find it. Yeah, it's going to be slanted. That's true. This is what you have to do to find it. You have to divide the numerator by the denominator. You will end up with a linear equation. That linear equation is the oblique asymptote. So let's do an example. Aw, what do you mean aw?
I have to divide the. I actually got to do the equation.
You gotta actually do it. Let's do this one. I think that's a good one. This is guided practice 4B on page 135, in case you care or want to notate that.
135.
Whoa, this window thing changes everything.
What is that?
But that's what it is now, the window. I'm going to change it by 2.
4B.
And now it's that.
What is that?
Okay. So, what is the degree of the numerator? 2. Degree of the denominator? 1. It's got an oblique asymptote. It also has a vertical asymptote where?
Somewhere.
No, there's
At 0.
3 halves.
And x equals negative 3 halves,
Yes.
which is negative 1 1/2, right? Set this equal to 0, solve. Put your frickin' calculators down.
I was looking at the window for the other.
Good. Stay where we are.
Stay focused, Reese.
I am focused.
You're watching TikTok on the
You're okay, but you're also distracting your neighbor.
I'm curious.
So we need to divide the numerator by the denominator, correct?
Correct.
So, how do we do that?
Synthesis.
We can do synthetic, sure. That's true. What's going to go in the box if we do synthetic substitution?
Negative 3
Negative 3
halves.
halves.
I just did 2 plus 3.
No. Because this has got to be 1, right? So we're going to divide everything by 2, right? I don't know why I wrote 5, because you said 5. Negative 3 halves, right? And then what's going to be here?
1. And then
1 half.
4.
no.
Negative 2. We got to divide everything by 2, right?
Oh, okay.
And then 1 half.
And then 1 half.
So we just did basically a preemptive step.
No.
Well, we did this. We just wrote it. We just
killed the 2.
we just did it in our heads. But that's what we did.
1 half of 3 halves is
1 half.
Negative 3/4.
Negative 3/4.
yeah.
So it's negative 2.
It's National Taco Day.
Oh, that's funny. I didn't mean to make an obnoxious one, but that's fine. Not a problem. Keep going. Negative 2 plus negative 3/4 is
Negative 2 3/4.
Which is, hold on.
Negative 11 fourths.
Yes, negative 11.
Ooh.
then negative 3 halves times 11/4 is what?
What?
Negative
3/8?
33 eighths.
Yes.
Positive 33/8.
Yes.
Negative
33
3/8.
And we don't even care technically, but what is 1 half plus 33/8?
Why don't we care?
I'll get there.
It's
What, that's 4/8.
1 half is 4/8, so
37 eighths.
37 eighths.
37 eighths. I thought there-
According to Key, we did make one mistake.
Where?
I don't know. And I don't like that.
Uh-oh. Stinky.
Shut up.
No, I was talking about the stupid noise you just made. Because according to the Key, that should be negative 5/4, not 11/4.
I think the key's wrong.
It's possible. It's not impossible.
No, it's not.
No one has ever proved me wrong.
You're wearing a Tebow shirt.
Yeah. X squared minus 4x plus 1, 2x plus 3, plus 3.
I don't know. Look at the shirt. It's actually pretty good.
Divide that. Make sure my brain is not braining wrong. That by that. That between 2x, all that junk.
Oh, I think it's like 60% cotton.
Okay, yeah, I don't think we did anything wrong. We may do one more just to sanity check. Okay, so we have a oblique asymptote at y equals 1/2 x minus 2 3/4. Let's start graphing the thing.
Wait, we don't have to put.
No, we don't care what the
plus
we don't care what the
37
remainder is.
minus-
We don't care what the remainder is when we're doing these for this asymptote.
I like not caring about stuff. Completely ignore the annoying. Exactly.
Okay,
That's what I do with people. Yeah. Completely ignore the annoying part.
so go to negative 1/2. Put a vertical asymptote.
How do we go to 1.5 x minus 2 3/4?
What are you talking about?
To put another asymptote. How do we do
We go down to negative 2 3/4. We put a dot and then we go up 1/2. Just like we've always,
that?
just like we always have graphed
I
lines.
forgot about slow.
We're going back in pre-algebra.
I forgot about slow.
Is the line accepted? Is the slope?
Okay, we got some asymptotes right there and right there.
I liked it until.
Now we need to figure out where the graph exists in these spaces.
Aww.
It doesn't.
So we need to find P of x when x equals, how about negative, whatever that is, 2, negative 10, -1, 0, and 1. Let's try those. And maybe +10 for good measure. Ready, go.
What happened?
I forgot to make a fraction.
Looking for my. Landon, did you see my thing again? No, I
No,
haven't.
I didn't. For what's actually done.
1.2, nothing's wrong. Thank you for your vote of confidence. Oh, look at that. Somebody bumped the thing. Dork
I
wads.
would never. It was Landon.
I would never. Is that really?
It's definitely Malcolm.
Yeah, it was Landon. I watched him do it. I just didn't.
I watched you do it.
-2 is.
How do we find the number of asymptotes? You're going to have to go back to last week's class, whoever you are. Okay, where are we at?
-2 is -13.
I'll give you a hint. It's the degree
It does have to do with the degrees.
-1
of the
is
numerator.
-10 is what?
Maybe I'm
I
sure.
thought I was going to get that, so I went to -1.
Okay, is 6,
Yeah,
0,
is 1/3.
1/3,
My
1,
calculator said no degree. I think
Is
it's
-2/5, 10,
Oh, man, I have to do that. 61 divided. What was that number? 23.
23.
No, it's not 23. I got it.
Oh my gosh.
It's 2.65
At -10 or 10?
at 10.
At 10. 2.65. And then what about -10?
I figured you would have picked that up by now.
-8.294.
-8-ish.
Oh, you're gonna have to run the first.
Great. It's -2, -13. So down in here, right? -10 is at -8, which is going to be up here. So what this asymptote continues on forever. Almost always when we have one of these with the slant asymptote. Now, if we have other vertical asymptotes, all bets are off. We do weird things. When there's a single vertical asymptote and a slant asymptote, it's almost always like in this section or in this section, and just basically following the asymptotes. So that's what this one's going to do. It's going to be in this chunk, and it's following this asymptote. You could figure out, you could like put in enough numbers to get this curve perfect if you want it, but we're not worried about that with what we're doing, right? So 0 and 1/3 is right here, so it's going to be in this chunk. So it's pretty much probably going to follow this, right? And then 1 at -2/5. So here, so that's honestly pretty good for our curve, right? So then there, and then there, and then done.
Yay.
Let's do one more and assume that they didn't make a mistake in the key twice, just for my own sanity. This one's even a little bit easier technically.
Would there ever be a graph in the other quadrants, like the other way?
It wouldn't be a function anymore if there were
Oh, because it wouldn't pass the horizontal
vertical line.
line. Or vertical line. Yeah.
Horizontals for if there's an inverse.
If it was like, but if these weren't there, if it was just the.
Yeah, it could be in the, yeah, that's why we needed the points to know whether it's going to be here, or, yeah, any of those, yes.
Both in the top and both in the bottom.
Yeah, it could be, it could be.
It just can't be both in the left or both in the
Right, it wouldn't, yeah, there's probably something wrong at that point. You wouldn't be able to graph it in your graphing calculator in that part of the graphing calculator without giving you an error. You could graph it in the graphing calculator, you just have to be in the relation graphing chunk of the thing. All right, so let's do one more. We'll do 4A, just for my own for my own sanity, to make sure
If you're locked in, you'll remember.
we're hitting in a good place. H of x equals x squared plus 3x
I remember it goes to itself.
minus 3 over x plus 4. The degree of the numerator is 2, the degree of the denominator is 1. It's got a slant asymptote, no horizontal asymptotes. It has a vertical asymptote at x equals -4.
Yay.
We use this evidently to study control systems. That sounds cool. Sounds like you're not in high school. Sounds like you're in college.
Maybe he's not in college. Maybe he's in his job.
Maybe it's his job. Yeah, that's true. Okay, anyway, so we're going to do this division, right? To do the division, what do?
We do the syntax.
What's going to be in the box? -4. 1, 3, negative 3, right? Bring down the 1. Negative 4 times 1?
Negative 4.
Negative 4. 3 minus 4 is negative 1. Negative 4 times that, we don't care, but it's 4 and 1. Great. So
no matter what the remainder is, we don't actually.
now this one matches the key. So good, for my own sanity. Hey, we don't even necessarily have to finish all of it, but it has a slant asymptote at y equals x minus 1. What was y'all's question?
So even if it doesn't matter what the remainder is, we don't need it.
If it's 0,
Yeah, for the remainder, yeah. So, actually, that leads us into our next topic.
Oh no.
That actually, you will kind of like this topic a little bit, right? Because, so if you have 0 as the remainder, what is true about this?
It's a factor of that.
It is a factor of that. So if it's a factor of that, then, excuse me, if it is a factor of that, then our line, then our function doesn't have a slant asymptote there. It has a hole there.
Oh no.
So if the remainder is 0,
Not the
then
hole.
it has a hole instead of a
Hole is not that.
factor.
I hate the holes.
Why?
I always forget about it. Yeah.
Yeah. So remember, if it has a hole, then the denominator is a factor of the numerator, and there's a hole there, right?
Holy cow.
Yeah. So you can finish that. This is whatever else. That's all we really need to say about a hole. Although we may do one example of one that's got a hole. Let's see.
How do we find the hole?
It's going to be there. Like in this doesn't have a hole, but it would be at -4. And if this was, yeah. Let's do an example of one. Time is it? How we doing? Not quite as good as I wanted, but that's all right. That's all right.
For a watch.
You're really struggling today, Bob.
Okay.
It's not good.
He has a watch on.
Malcolm, figure out what control systems guy is saying while I write this example on the board.
Come on, Rob. Hurry up.
What? Check out control systems guy.
No. Control system guy. Control system.
All right. So
I have to use auxiliary equation that differentiate if I'm not wrong. I have no clue what you just said. It's hard to read from this angle, okay? Just read it, Reese. Read it the correct way.
If it is 0, we might have to use auxiliary equation and then differentiate if I'm not wrong.
Auxiliary equation.
I'm not sure if we're talking about the same thing.
Malcolm. What is he doing? Look at it.
So oftentimes if the denominator is 0 and we're dividing by 0, you would do some differentiation and all of those things, but definitely not in this context. Okay, so something that we haven't really done, because it hasn't really been possible in the examples, is if it's factorable, factor it, right? That's going to be a lot easier. So let's take a look at this guy. It's going to be factorable. We know it's going to be factorable because of the example. It's going to because of what we're trying to do. Let's factor the numerator. What does it factor?
X, and then it's
-3 and 1.
X, 3, 1, negative, plus, all works. Great. Let's factor this one.
X, -5,
5, 1, negative, plus, all of it works. Great. Great.
Oh wait, we can kill stuff.
Kill it!
We can kill stuff.
We can kill stuff. That's
I like
true.
killing stuff. Wait.
Our graph is going to have a hole where?
At,
X equals
wait, it
1.
will have a hole?
It's going to have a
Hold
hole.
on, let me do this division.
You don't even have to do any division. You just look at it. Where is the hole going to be?
X equals
At
1.
At -1.
Gosh, dang it. That was close.
You're so close here.
What?
Why is it a negative?
Because if I put a -1 in here, what's going to happen? Negative 1 plus 1.
Oh,
Here,
so would it also have one at 5?
Nah, it doesn't have a hole at 5.
it doesn't want to.
It has an asymptote at 5.
Oh.
And how do I know whether it's a hole or an asymptote? What am I looking? What am I comparing? What's different about this factor versus this factor if I look at the whole thing?
Oh, that was
It can go away.
These ones match. It's going to cancel. So there's a hole there, right? So it's got a hole at x equals negative 1. Great. It has a vertical asymptote. At where? At 5. At x equals 5. Now, how do we know what the rest of the graph? Don't put your calculator down. Put it down.
I thought we were getting to the graph.
Not there yet. We're not there yet. We're not there yet. How do we tell? How do we know what the rest of the graph looks like? In algebra 2, almost always, when we did one with a hole, we ended up with a line with a hole in it. But you ain't in algebra 2 anymore. You're in pre-cal. Because this is not going to be a line with a hole in it. It's going to be something with a hole in it, but not a line. It's not going to be a parabola.
Curvy line.
It's going to be something curvy. How do I know what it's going to be? What do you think?
X minus 3 over x minus
Yeah, it's going to look like that one. It's going to look like x minus 3 over x minus 5, but with a hole in it. What is that one going to look like?
That one's going to look, hold on, that's an asymptote at 0, y equals 0, right?
It does. It has a horizontal asymptote at y equals 0. How do I know that?
Because the degrees are equal.
Because the degrees are equal.
Wait.
1 and 1 is the same number.
Wait,
I thought that, oh yeah, 1 over 1.
now I can't remember if
What
it's
did you ask? Y equals 1?
And it's
Oh,
also,
yeah. They're equal. Yeah. The other way, right? Yeah, you're wrong. You're leading us down a wrong path. When they're equal, it's not at 0. That's wrong. That's incorrect.
Oh no, that's when it's greater. Finally, right. Instead,
You usually have
1 over 1.
Yeah, it's at this over this, right? So it has a horizontal asymptote.
I just haven't locked in.
You just locked in. Well, welcome to class. At y equals 1. Great. Let's get all our asymptotes and things drawn on the board. All right. We've got a vertical asymptote over here at 5. 1, 2, 3, 4, 5. It's kind of weird. Speaking of 5. So far in pre-cal, there's been like 0 people on this little stream. And today, there are 5, apparently.
What, actually?
I thought there was just
I thought there was just 5.
control guy.
Nope.
Yeah, there's 5 people. Holy crap.
Y'all might be famous.
No, we're not gonna be
Cancel
famous.
because we
Bunch of high school pre-calculus boys.
Yeah, I'm also gonna get.
Okay, so we need a little table, right? Let's grab us a little table. X, C of X. We really, I mean, we can pretty much make a guess what this is going to look like, but let's grab a few points just to be on the safe side. Let's go with like 2, 3, 4, right?
How about negative
5,
1?
negative 1, and 1.
Yeah, I like that too.
This is fine. And then at 6, 7, 8.
What? What was that?
Now you pull out your calculator. Now you did, or you can probably do these in your head. TBH.
2 is at 1/3. 3 is at 0. 4 is at negative 1. 5 is at error.
He already
6
had
is
it.
at 3. 7 is at 2. 8 is at 5/3. Or 1 2/3.
Yes, 5 is an error, Reese. We haven't asked him to go to 5.
I was just reading down the line.
5 is an error. That's true. We also know that there's a hole at the negative 1, so we need to know what the y value of that would be. So what do we do?
Plug that number.
Plug negative 1 in over here, right? Because if you do it with the original and your thing, it's also going to give you an error, right? It's also going to be -1 is an error, but we put a -3 in here, that number, -1 in there. So -1 minus 3 is -4.
Over -6.
-4 over -6, which reduces to 2/3. Great. So there's a hole at, specifically, -1 2/3, right? Great. So let's graph the thing. So we've got 2 1/3, 1, 2, and 1/3, so about right there-ish. 3 and 0, 4 and -1. And the hole is at -1 something, right? -1 2/3 is a hole right there.
Wait, that's 1 2/3.
That's 1 2/3 of the negative.
Oh yeah, my bad.
1 is.
I was like, that is no bueno.
Yeah,
What is it?
hole right there. 1 is at 1/2. What did you say?
So that we have 1 between the hole and
Oh yeah, that I can see where that trend is going, right? And I don't even have to look at the points and know that this one's going to be something like that, right?
Is it? It is.
Easy money.
Easy. Very easy.
So make sure when you're doing these, you write down where the hole is and mark it clearly, right? So that you're not in a weird way. How are we doing on time?
There's 7
E.
people.
Oh, that's disappointing.
It's disappointing. That's like the most ever.
Because you name both the axes. I think we should call one Bob and the other one George.
What?
I don't know what you mean by naming both axes. Name both.
Question?
Oh, put an X and a Y. Oh, go jump in a hole. There. One's X. You know which one's X and which one's Y.
Xavier and
Ah.
Young Life.
I think that is unfortunately all the time we have. We're gonna have to do solving rational equations next time.
Until next time.
So your homework today.
Someone said, I really thought functions curves are related to limits only.
Well, this is pre-calculus, so we are prepping for limits and all of those things. So I think you're probably on the right track. Whoever you are, wherever you are.
Victor says, thank you for teaching.
You're welcome, Victor. I'm glad it was useful.
You need to get like one of those little bots that reads it.
Yeah, right? That'd be fun. Your homework.
Super
It
chat.
went from 7 to 4. We're losing viewers.
Well, it's
It's like
because he said that's all we have time for. Just have the computer go, Victor says, thank you for teaching.
That would be so awesome. You get like 45
So you-
people that could watch the stream. We start getting thousands.
He starts blowing up, right?
Yeah.
Uh,
Easy peasy. Goodbye, kids.
Yay.
Goodbye, cruel world. Goodbye, live stream.
Yeah. Bye,
How
Victor.
do I get extra credit here? Well, you know,
Just try hard.
doing math.
Go up to your teacher and be like, give me extra credit.
Which grade? These are sophomores and juniors. Actually, I think they're all sophomores. You're all sophomores?
I'm a junior.
Juniors?
We're all juniors.
Oh, you're all juniors. Yeah. This is pre-cal. Juniors and seniors is what I'm trying to say.
You're a senior?
This grade
Yes.
is juniors and
What?
seniors in high school.
You mean, what? I'm turning
You need to come
17.
talk